Let's do this problem on Geeks for Geeks. It's called longest k unique character substring. It's a medium problem. The problem says given a string, you need to print the size of the longest possible substring that has exactly k unique characters. And if there is no possible substring, then print -1. We're given a bunch of examples to better understand the problem. The first example, we're given a string s and the value of k is 3. So the objective is to look for the longest substring with 3 distinct characters, which in this case happens to be CBE, BE, BE, with 3 distinct characters being C, B, and E. In this example, we're given 4 A's, and we are asked to look for the longest substring with 2 distinct characters, which in this case is clearly not possible. So we output -1. I'm going to solve this problem using 2 iterators I and j, and use the sliding window approach. So what I've done so far is initialize values of I and j to 0, and I'm going to run my j iterator through the length of the string. Say my j is less than the length of string, and what I'm going to do is every character I encounter at the jth index of the string, I'm going to store its count in a map. I'm going to get around why I'm doing that as I progress. For now, let's go ahead and create an empty map and record the count of the character at jth index inside of this map. So let's say if the character at jth index is not a map, then set the key as 1, else increment the key by 1. Okay, now as I run through the string, if the length of this map, which is basically going to denote the number of distinct characters we've encountered thus far, is still less than k, I would like to keep incrementing the value of j, so I can keep adding more elements into the sliding window. In order to do that, it's pretty straightforward. So I'll check if the length of that map is less than k, I'm simply going to increment j. Now if I do reach k, which would mean I have encountered 3 distinct characters inside of that substring, I know for a fact that that substring is a potential candidate for the final output, which is 7. So in order to store the length of that substring thus far, I'm going to create a new variable mx, short from max, and I'm going to initialize that as -infinity. So import sys. There we go. And what I would like to do is every time I think that I have a potential solution, I'm going to check its length against the length already stored inside of the max variable and take the max of the 2. So I don't have to loop over my hash map again. And that is going to reduce the complexity to O of n. So I can say something like mx. Alright. Now we might run into a situation where the length of map, which is the number of distant characters we have encountered so far, exceeds k, and in that case we would like to slide our window and get rid of all the operations associated with the ith element inside of that sliding window, because it's the first one inside of that sliding window. So what I'm going to do is check if that value exceeds k, and if that's the case, while that value is still greater than k, I'm going to check for that ith index inside of the map and decrement it by 1, and if that value becomes 0, I'm also going to reduce the size of that map, because I'd like to reduce the size in case I don't need that ith variable anymore. So I can do something like this s of I, and that's the key. Decrement that by 1, and if that becomes 0, I'll simply pop it actually, and then increment I. So I'll keep doing that until I have successfully removed the first element inside of the sliding windows before adding more elements into it. And in theory, MX should now have the length of the longest substring with 3 distinct characters. Yep, there we go. Thanks for watching.